Okay, that last video cut off there right at the very end on me. Only had one step left. Of course, this is where I had gotten to previously, and in order to get dy dx by itself, I needed to divide by the 4 and divide by what I have in parentheses here. So if you divide by 4 though, because I had factored a 4 out on this side, so if when I come over and divide this side by 4, the 4's are going to cancel. So just instead of taking a whole step to show that, I just went ahead, marked those out because they will end up dividing out. So then you're left with this on the right hand side, which will be your numerator, and of course this is what you're dividing by, which will give you this as your final answer. Like I said, that's all that was left for my video. I had accidentally cut off there. Okay, so still continuing with implicit differentiation, but going back to some things we've already done a few times as far as finding the slope of the tangent line or finding the equation of the tangent line. But, you know, having to do the derivative implicitly, of course, is the part that's different here. So determine the slope of the tangent line to the graph at the given point. So first of all, I've got to get the derivative, which this will require implicit differentiation to be able to do that. Of course, I have a sum, so I'm allowed to differentiate those terms individually. So my first term containing only x, I'll just take the derivative there as usual, plus, okay, now taking the derivative here using your power rule, that would end up giving you 8y dy dx. And of course the derivative of a constant is just 0. Okay, now you could do this one of two ways. If you want to go ahead and get dy dx completely on one side by itself and then substitute in your x and your y value, or you can substitute in your x and y value and then get dy dx by itself. I'm just going to go ahead with the process we were doing earlier and get dy dx by itself, and then I'll take care of substituting in my values. So I would have 8y dy dx is equal to negative 2x. Then I'll have to divide by 8y. Okay, so this will then reduce to be negative x divided by 4y. So now, of course, this is our derivative, and if I want the slope of the tangent line at this point, then I would need to now substitute in my point. Okay, so dy dx is equal to, so that would give me negative square root 2 divided by 4 times negative 1 over square root 2. So just substitute in my x value and my y value. Okay, doing some simplifying. Okay, of course you have a complex fraction. So you can use the technique that I've shown you several times in the past. Of course, this is understood to be over 1. So remember, you can multiply, the top times the bottom and then the two that are in the middle. So when you do, of course, we know this is going to end up being positive because I've got a negative divided by negative. So I'm just not even going to worry with my negative signs anymore. So square root 2 times square root 2 is 2. 1 times 4, of course, is 4. And therefore that reduces to be 1/2. So this would be the slope of your tangent line at that specific point that was given. Okay, next, just actually doing the same thing that we just did, but taking it a step further, because this time you're asked to find actually the equation of the tangent line. Now, what I would suggest, well, I don't guess it really matters. If you wanted, you could distribute the x squared here. Now, you're still going to end up having to do product rule whether you leave it this way or whether you distribute. But let's go ahead and distribute. That might make it a little bit easier for you to follow. So I would have x to the 4th plus x squared times y squared is equal to y squared. So I've not started the derivative process. That's just simply rewriting the problem if you choose to do so. Okay, so now taking the derivative, of course your first term, this contains only x, so that would just be power rule 4x cubed. Now this is going to require that you do your product rule. So first function times the derivative of the second function plus second function times the derivative of the first function. So of course here's the only place I had to put the dy dx is when I was taking the derivative of the second function because it was in terms of y. Okay, now on the other side, of course this is in terms of y, so you'd have to put your dy dx on that as well. So you would have 2y dy dx. Okay, so I've got 4x cubed plus 2x squared y dy dx plus 2xy squared equals 2y dy dx. Okay, so I need all my terms containing dy dx on one side. So I'm going to bring this term down as it is. And I'm going to subtract this term. Of course, each of these terms would have to be subtracted. You need those on the right. Okay. Now, you do have some common factors here other than just dy dx. Like you could factor out a 2, you could factor out a y. I mean, you're going to end up substituting the values from that point in, so you can factor those out or not. That's your option. But I'm going to go ahead and take it out. So I'm going to take out 2y dy dx, because I can see where there's some stuff I can cancel with over here. Okay, so that will leave me with just the x squared, and that would just be minus 1. Now over here I have a 2 that's in common and also an x, or if you want to take out negative 2 you could. So 2x, if I were to factor this out, I'm left with negative 2x squared minus y squared. Okay, so now I need to divide. Okay, so to get dy dx by itself, so my 2's are going to cancel out. Like I said, you really didn't have to do that. You'll get the correct answer whether you do that step or not. That's just an option if you wanted to. Alright, so there's your derivative. Now, we've got to substitute in our point, because in order to find the equation of the tangent line, we also have to know the slope of the tangent line. Okay, so that's the next thing that I need to do is substitute in for here. Alright, so my x and my y were both square root 2 over 2. So I have square root 2 over 2 times negative 2 times square root 2 over 2 squared minus square root 2 over 2 squared. And then on the bottom, square root 2 over 2, and then square root 2 over 2 squared minus 1. Okay, those are going to cancel. Okay, now here, of course, square root 2 over 2. So you square the top, square the bottom. Okay, same thing here. Same thing here. Okay, so if I were to multiply here, then I would have negative 4 over 4 minus 2 over 4 divided by 2 over 4 minus 1. Now, whatever step you want to take to simplify that, that's up to you. I'm just going to go through and multiply each term by 4. So if I multiply, like I said, both terms on the top, both terms on the bottom, I'm just multiplying by 4. Then I get -6 on the top, -2 on the bottom, which reduces to be +3. So, like I said, whatever process you want to take on these last couple of steps, that could vary. All right, so now that's just my slope. So now I'm asked to get the actual equation. So remember, that's going to be your point slope. Okay, so your point slope formula. So your y was square root 2 over 2. Found your slope to be 3. And your x value is square root 2 over 2. Okay, so we need to distribute the 3. And then we need to add the square root 2 over 2. Of course, you've already got a common denominator. These are like terms, so this is just a -3 plus 1. So -3 plus 1 is a -2 square root 2 over 2. And then your 2's end up canceling out, so your equation for your tangent line is y equal 3x minus 2.